Hi everybody. So in today's video we're going to be using the application state to track 1, the time it took to beat the level, and 2, the number of moves it took to beat a level. We're also going to get rid of our save system and we're going to use the application state instead. And then if we have time we'll start looking at how we're going to be storing the time it took to beat a level and the number of moves it took when we're actually saving. But I think that's going to be for the next one. Before we actually get to that though, I did find a bug while I was testing. So let me actually update our save.txt, so R1. So now our max level beaten is level 0, and if I play and I do this, you can see level 2 is unlocked when it really should not be. So let's put that there, and basically the problem with it is this right here. This is basically always going to be true. So what we do instead is we change it to just use application state again, but this time it's the selected index. So if the selected index is the max level beaten, then we should increment max level beaten and we should do something else. I also want to change the name application state to something else. So I'm going to make it like app state, just because it's kind of insane how much stuff is going on here. I think the problem is it didn't change it here, so let me just do this. All right, if I make it, we have a problem in menu C++. It didn't get changed at line 29, so we can fix that. The other one was on line 51, so we can fix that. Now let's take a look. Looks good to me. Let's play level 00. Nothing happened. Let's beat level 1 real quick. And we're good. All right, cool. So that's the first thing we wanted to do. The next thing we want to do is we want to fix, or not fix, but change the game application state to actually include the moves and the time. And you can see I did it in the previous video, so we can actually just go and implement it. So let's go to game header file. And we'll also go to level progression C++. We don't need to be in the game header file. We can just close that. We're in the level progression, so we know the level starts when we get to here. So what I'm going to change this to is I'm going to do app state clock start, yeah, is equal to clock. So this is a case where it may be worthwhile to consider our state class to have like a virtual void on enter equals 0 and virtual void on exit kind of thing, right? Because then what we could really do is on enter, right? We could do in the game class, we could change on enter to set the start time, and then on exit we could set the close time, and then we could do our stuff. But for me, if we don't need it, we're just not going to do it. So for right now, we don't need it. But I have a feeling when we get to breakout, I'll end up just adding on enter and on exit, because that will just make everything a lot better. In terms of actually the implementation in the main C++ file, like our driver, all the way down here, right? This is pretty easy. We could just have like a temporary state. And if the temporary state is not equal to the current state, then we would call on exit on the current state and then change the current state to the temporary state and then call enter on the temporary but now newly current state. But we don't have to do that. We are going to keep it simple. So just as a reminder, our level progression, right, we just set the clock, which is the current time. I know there's another way, which is probably a little bit more like C++y, which is to use like chrono, but personally, I don't really care about perfect accuracy here. I just want some kind of clock. So let's go into the game C++ file. The first thing I want to do is I want to track the number of moves a player took. So because of that, let me do app state moves equals 0. So we're just initializing it to 0. This is where we'd also put in on enter. And then we can do plus plus app state moves, right? Because this was a valid move, this was a valid move, this was a valid move, and this was a valid move. In this case, right, we want to do app state, state moves is equal to 0, and app state clock or start time is equal to clock. If the player is quitting, we don't really care about the moves or thing because the level progression will reset it, so we can just leave it. Okay, so before we actually go into updating anything, let's go into the rendering just to make sure everything looks right. So I'm gonna put to 0, 0. Actually, let's do like the MB print W thing. So 0, 0, and then what we want to print is moves, and I think I need to do like %I, and then it's app state moves. We're not bothering with the clock and rendering that right now, but we can actually. So let's go one down. I believe this is Y. And then what it's going to be, start time, clock minus that. I don't believe that's going to work well, but let's just see what happens when we do like RD. I'm assuming this is not going to look very nice, but that is okay. But that actually does look decent. And did we already have that unlocked? I think we did. Let's just make sure. But I think that's looking pretty decent. So yeah, that looks fine to me. So let's get into, we don't need these anymore. We can maybe reconsider like printing out the move state at some point. We won't do the actual time state, I think, in the rendering at any point, because if we did that, then we'd actually want to change the rendering to like a real-time thing where it's showing the time like ticking up by second by second by second, which I don't really want to do. So we're in here, we're correctly setting the moves, but what we're not doing now is setting the end time. So the end time is only relevant right here, right? The end time, I'm just going to put it in the application state. I don't think, we're not going to keep this double end time. I'll do that. Right, and it's going to be app state end time is equal to clock minus app state, which is what we did before, sorry, start time. But remember, it's a double, and we want to change this into seconds. So I'm actually just going to look it up real quick. Clock T 2 seconds, right? And we can just see what it is. And I guess it's already in seconds is what they're saying. What's the unit of clock? We can actually see like clock T unit, because this is right here. And it's the processor time. It has an implementation defined range. Let's see what clocks per second is. That doesn't really help. So CPU use time %F seconds. So I think we need to divide by clocks per second, but yeah. Yeah, we need clocks per second. Okay, so that's totally fine. End time, right? So all we do for this is this. And they were casting it to a double at the end here. So we'll do that, right? And then what we'll do is clocks. What was it? It was clocks per second, yeah. All right, and that's that. So there's our end time. And we don't care about that because we're not actually storing it yet. But what we're going to do is we're going to get rid of the save system stuff now. So let's go to application state, right? And we're going to have two functions. We're going to have void save. What we could actually do is a very like OO style of it, which I don't necessarily love, to be frank. Right, but if we just do it in the constructor and deconstructor, like all the code just goes away, right? Because once this goes out of scope, it's going to call its destructor, and then we'll be able to save. And when this is put into scope, we'll load it from the file, and it will just work. So that's kind of cool. So let's actually do that. And so what we'll do is, yeah, I think we're just going to make another one. So touch src. Application state, change it to C++. We'll yank these, C++, include application state, right? Pretty simple. And now we're just going to define these two functions. Cool, cool, cool. Good enough. Okay, so now we're going to go to save system. I'm in all caps, oops. So get data, right? This is just the constructor. Fun enough fact. What we need is we need the constants from this one for this to work. And we also need, let me put it like here. We need fstream and that's it. Okay. So in this case, we're unable to load in the data, so it's returning some kind of problem. In our case, that basically means we can't read in the data. So what we're going to do is we're just going to call return, and the application state defaults to 0 for everything, and I'm okay with that. We don't actually need to basically say like, we don't basically have to just destroy everything, right? But we do want to log the error. Error could not, oh no, we don't need to do error. Open, save, file, resetting. So now we just do this, and now instead of doing the num data, right, we don't even do this. What we just do is max level beaten. And then, yeah, we should do something here now that we have our log system. So I'm going to come back to it though. So ss get data is donezo. Now let's take the save data. We can take that, and now we can actually just remove save system. And that looks a little bit better already. There's going to be some errors, obviously. We're going to need to, for that C error, we're going to need a IO stream. Well, actually, we're not going to use the C error. So let me, and we don't need to exit on this one. This is just an error. Could not write to. That looks good to me. Then we'll just return. Otherwise, right, we can just do max level beaten, and that's totally fine. Okay, So the other thing is I want to be able to kind of log out this generically. So let's double check how to do that. Log exception generic C++, right? So we're just going to catch all the exceptions. And so they're saying, okay, so that looks totally fine for me. So what we'll do is log error, and then we'll do like, I missed the S in standard dot what I think it was. And I think I need to change this to, what's the include, std accept. This, is this gonna work? Let's see, auto exe equals std current exception, and then exe dot, and are they saying I need to do like this? No, that doesn't look totally right. Okay, so the other way to do it is just to do it like this, I guess. E, right? And then what we can do is this e dot what, and that will just log the error. And I believe that's, yeah, I think that's about right. We don't really care. This person's basically saying like they could throw an integer for example, and then we wouldn't catch like anything else. But in our case, we're using S2I. We could see S2I exceptions if we really wanted to be like exact, right? And we can just do like this, S2I, right? And there's out of range, and yeah. So I guess there's only one. No, there should be other ones like yeah, because like if there's like if we gave it like a, I guess that they may have a way to handle that, but I kind of just want a generic exception, so I don't really have to think about it. So that looks good to me. I no longer need this import. And now if I make it, we have our save system stuff to get rid of. So game C++. And I guess there's something to think about, right? Because now we no longer have our, oops, I didn't mean to do that, RMSRC save system. Okay, that looks good. Did I get the main C++? That fixes it. Save system. I'll do application state C++. There's one other thing I'll do, which will just be void save, right? And then what I'll do, because I lost auto saving when I did this kind of destructor pattern idea. So I'll do application state, save, right? Put this in here. Now I do save, so at least we don't have all this duplicate code. And then I can go into game C++. I'll fix this in a second, and it's just appstate.save, and this is autosave. And then the problem is that this needs to be an arrow. This is just poorly spelled. And then this I lost at some point. Let's see. Come back to that in a second. Let's go to main.c++, get the save system. So I don't need this. I don't need this. I don't need that. I don't need that. 64. So let's see what's going on now. Game C++. I think I've forgotten to fix that for a while now. And then we'll see if the format thing is fixed too. It is. So now if we do Sokoban, Everything looks good. We're still save. Let's check if we're still saving by changing the save.txt to R1, and then we'll make it. Then we can run it. And that looks good. Now if we run it again, is it still unlocked? It's still unlocked. So yeah, that's working. I was hoping that it wouldn't take so long, but there's always just a lot of little things to consider, and they end up taking time. So this one's about at 20 minutes, so I'm going to stop here. In the next one, I know I keep saying that, we'll get to actually updating the save file stuff now, but as you can tell, I think we've made good progress, and overall the design is a lot cleaner. So yeah, I'll see you on the next one. Hope you enjoyed this, and bye.